Hey guys, how's it going? Tom Greenwood here. This is my Everyman Carpentry YouTube channel, talking about things related to doing carpentry and building houses and all that fun stuff. Anyway, somebody asked me to talk a little bit about joists, and I just remember that even though I've got 3/4 of the floor laid, we can still see some of the joists that are in place in this house that I've been working on. If you guys are curious about this house, you can go back and watch videos related to the 100-year-old house. But we're laying the subfloor down, we'll have it down, and then the house will not be floating anymore. So joists, what about them? Joists are horizontal framing members that support floor structures. So yeah, that's a thing, I guess, a definition. Anyway, joists are the wood that holds up the floor. And in modern framing, what whole lot to be said about it. But in modern framing, there's some stuff that governs the way joists, the size of joists you use. Okay, so what we have going on here is that if you've watched the previous videos, you know that back in here, there's you can see that right there. That's a big beam. They would call it a girder, but it runs the entire length of the middle of the house, and these joists run and rest on that girder, or that beam, or as I like to call it, the spine of the house. Okay, so they're running from over there, sitting underneath that wall, and they're coming over all the way over here. And what I do, what a lot of people do, is first we came and you take the joists. These joists might move, they might have a bow, like a rainbow, and what we call that bow is crown. I have a video on the common defects of wood, and crowning is a real common quote-unquote defect. Trees don't grow straight. They don't like, nothing in nature likes straight lines pretty much, except maybe like crystalline structures that grow. So as you can see, I've got this little, some people call it a frog tongue. It's a V that points up. What I did is I looked at every single joist in this entire house, and I determined which way the crown was, and then we put a little tick mark on it, and that tells us the crown goes up. And the point is that over time that crown will flatten out, and you'll get an average of levelness throughout the entire house between all the defects and the wood. It'll all just kind of even itself out. So when you have the joists, they run from, this is a block wall behind this insulation. This is our sill plate. You have a joist, and then on the outside of the structure, if you see this end of this tube line right here, this is called a rim joist. Let me show you a rim joist from the outside of the house. So anyway, you have your joists running parallel to one another, and then you have your subfloor on top of it. And then what you do is you get your joists perpendicular to your sill plate, and you have a rim joist here. So sill plate, this is called a rim joist, and it's the joist that the inside joists tee into. And then I've got 1, 2, 3 screws. We're using screws on this project. Some screws, some projects you use nails. Depends on what the client wants, what the standard is. So anyway, we've got screws in this rim joist, and then the joist is running all the way to the other side over there, and then the same thing on the other side. It's perpendicular to this, and it's screwed in, and then we have our floor sitting on top of it, and we put 2-inch screws through the top of it. On a lot of projects, they use nails, but on this project, almost everything in this house is screwed together. So you get a much stiffer ride. It takes a lot of squeak out and gives you more power. So that's how it's put together. Is the joists are running from here to here, and then I have blocking in between. Now, blocking isn't necessary according to code. You can, every framing member that's less than 12 inches deep, so in top to bottom, you don't have to have it. But the blocking was put in here at the request of the clients, and blocking is a really good idea because the joists, the natural tendency of wood, not only will it crown like this, but it'll also bow like that. And what it'll do is it'll run weird. So what you want to do is this blocking keeps it pretty straight. There's a little bit of weeble wobble because nothing's perfect, but that blocking keeps it straight, and it also keeps those joists from turning and twisting and falling over. So it keeps them perpendicular to the sill plate, and it also provides stiffness between this joist and this joist and this joist and this joist. That blocking is sharing a little bit of the load. It's helping it stiffen up the floor so it won't wobble back and forth, and it won't let it roll. And there's different ways to do blocking. Sometimes, a lot of times, especially if you're underneath here, let's get back down, I'll show you. On the ends of these joists that I've got, I've also got blocking on the very end of them to keep them from rolling. So that right there is actually a piece of 2x10 that we cut and put in between it and then screwed on the either side. On these I did the same thing, screwed them in. So there's blocking there, and there's blocking in the middle, or on some of them we split it into thirds. So you have your joists running back and forth from either your girder and your foundation sitting on a sill plate on either side. You have blocking in place to keep it stiff so it doesn't roll, and also keeps it square and keeps it from like wobbling back and forth. And that's kind of like how you do your layout, okay? So that's like the basics of how a joist system will work in a house, okay? So the thing about joists is that there's a thing called International Residential Code. And what code does is it tells you how big your framing members have to be. Now, what I've used here is 2x10s, okay? And there's a mathematical formula that tells you, like, you can look up what's called the modus elasticity of a piece of wood, and it's a number, and I don't know exactly what the modus of elasticity is. I think it basically has to do with like how much it resists a nail being put into it or something like that. But there's this mathematical formula that you can plug in the span and the load, and the load is how much weight's sitting on the floor. You can put the span and the load and the type of wood and all these other factors in there, and it'll spit out a number, and what that number will be is a number of feet, and it'll tell you how far you can go. Okay, so that's all well and good, and if you want to, you can figure that out. But some smart people went in, some educated people went in, and they got all the different kinds of wood in the world, or a lot of the different kinds of wood that are in North America anyway, and they figured out what their span is, okay? So if you look at this piece of wood right here, it's got a number on it, right? And so that number tells you a whole bunch of things, but the most important thing for us is number 2 prime. Okay, now what that number 2 prime means is that this wood has a known number of knots of a certain size. It's a grading stamp. So the better the number, so you have like number 3, number 2, you have number 1, and then you have like super select, like top shelf stuff. But that stuff's like so expensive, it's not really worth building most of your projects with. So I go in the building code. It'll tell me number 2 prime. This is southern yellow pine under a load rating of 40 pounds live and 20 dead. That means that 20 dead means that 20 pounds per square foot of dead weight that's sitting on it. That's the floor, blocking, subfloor, regular floor, anything you might put on top of it. That is the house itself. It will hold 20 pounds of dead load per square foot. And then I always calculate for 20/40. So that means 20 pounds dead, 40 pounds live, which means live load is furniture, me, you, your dog, whatever it is you put in the house. So each square foot of this house should be able to hold 60 pounds. Each square foot should hold 60 pounds before this flooring system fails, okay? And what failure is inside the IRC is, I believe it is 1/360th of the span. So our span is just under 14 feet. These are cut at 13.9, and that gets us to the outside here and to the middle there, and really we're looking at about 13.5 feet. These number two southern yellow pine 40/20 will go out to like 14 feet 8 inches at a 2x10. Okay, so that 1/360th of the span means that if this is 13.5 feet across here, it can deflect 1/360th of that span, that number, before the floor will have been considered to fail. Okay, so according to span charts, I could have gone with 2x8s in here, but I didn't. The other thing is you can go, like, these are 16 on center, so what that means is from the center of this board right here to the center of this board right here is 16 inches, or from edge to edge is 16. Common framing for all houses is 16 on center, 2 foot on center. Sometimes you'll see 3 and 4. Those are really, really uncommon. Almost everything is 16 or 2. So 16 is, there are 3 members every 4 feet. So 1, 2, 3, that fourth one. So if we have 1, 2, 3, that's 4 feet. And then 1, 2, 3, now we're at 8 feet. Okay, so that's like the thing. So if it's 16 on center, it'll span however many feet, and it'll hold 60 pounds total per square foot without deflecting. One other thing that I do is, you see this floor right here? The floor butts up, right? And I'm supposed to have a little gap. So we'll have to gap this out a little bit. There's supposed to be about 1/8 of an inch. This is a little tight. We'll have to pry it apart. But I don't have a line that runs all the way. It runs down, and then it comes over, and it runs down. And basically, it's like you have no single straight line inside the house. Straight lines are fault lines. They where things fail inside the house. So when I lay it out, I have one there, and then another one starts there, and then the next one starts over, and we just stagger them out all the way down. So I know that's kind of a long video. I don't know if I explained exactly floor joists. There's a whole bunch of math that covers them, but for what I do, everything is 16 on center. If it says that I use a 2x8 in a space, I go to the next largest framing member, so I go up to a 2x10. Okay, because I always want it to be stronger and stiffer and last longer. And so, like, these engineered tolerances are like very narrow, and they will function, but if you add a little bit of meat to it, you won't have problems later on. So this whole floor should be like really stiff and really strong and not deflect, and be able to hold up for another 100 years. You know, my hope is that in 100 years, this floor will still be good. That whoever buys this house 3-5 times down the road will be like, man, this guy really cared about what he was doing. So to that end, like, we have the blocking in place. We use screws to put down all our floor. We use screws on the outside. We took the time to square off the ends and all of that stuff so that it would actually function as a superior flooring system. If you walk through a house and like the dishes rattle, that's not a good sign. Okay, you should be able to walk across the floor and it be quiet. So that's the goal here, is that they'll be able to put like little knickknacks or whatever on the wall. The paintings aren't going to fall off the wall. The glasses won't rattle in their bar and all of that stuff. It'll just be quiet. So the screws do that. The larger framing members do that. The blocking helps with that. It all adds up. Every little piece adds up until you get something really awesome. Anyway, I know that's a kind of a long video. If it doesn't make sense, or I need to like clarify some stuff, let me know, and I'll come back and like draw it all out for you and explain it in more detail. But I just wanted to get this video in of this project before we close the floor up, because we're like 30 minutes out from that. Anyway, hope you enjoyed it. Talk to you in the future. Bye.